Hello, my beautiful computer science students. Welcome to another lesson in Unit 4, Data Collections. This lesson is Lesson 5, Implementing Array Algorithms. We are going to be going through 7 of the most common array algorithms, and these are the 7 that are required for you to know for your AP CSA exam. So we're going to be going through how we implement these algorithms on one-dimensional arrays. After we go through those 7 algorithms, we then are going to finish our lesson with a conversation about arrays of objects. So we're going to be going through a lot of important information today. You're going to want to make sure you have your notes close and get settled in to go through the content together. The first thing I want to talk about when I talk about common algorithms for arrays, when we have an array of data, usually whether it's small or big, we have some common tasks that we end up performing on it. The algorithms we're going to create are kind of a snapshot of what these common tasks are. They happen so frequently, you want to make sure that you understand how they work and how they accomplish their task. Now, do you have to memorize the code I give you? No, right? We're not into memorizing code around here. But you will want to remember the steps. Okay. With each task I'm going to give you a set of tasks or a list of tasks of how we accomplish a goal, right? And that list is the algorithm, okay? So whenever you're faced with a task dealing with a one-dimensional array or eventually other data structures in this unit, you are going to want to figure out what are the steps I need to take to make that happen. And those steps make up your algorithm. So you're going to want to know those steps, okay? Now, again, the code that goes with those steps, you're going to be using them so often that eventually it'll feel like you have them memorized, but I don't want you to feel like you have to sit down and memorize this code right after this lesson, okay? Let's look at what I mean. So algorithm 1. One of the main tasks you're going to be asked to do is find a minimum or a maximum value from an array of integers. Okay, so we are going to write a method called max that returns the index of the largest number, the maximum, in a passed array of integers. So all of these are going to be writing a method. Some of them are writing a code snippet, but we're going to be writing a method. And the big thing with writing a method is that you want it to work for any array. So this is a array of integers. We don't know the length, so we're going to make sure the right code for any length. And you'll see in the comments right there, it's going to return the index of the largest number, whatever that element is. And the precondition, remember, a precondition is going to be something that we don't have to check, that we can assume is automatically true. And it's not something we have to write code to check. For example, this precondition says we are passed a non-empty array of integers, meaning that we're passed an array of integers and we can just write code assuming that it's non-empty. And the reason we want to assume that is sometimes the code that we write, it might have a compiler error or an index out of bounds error if there was nothing in that array, if it had no elements. But this is telling us we don't have to check for that. We don't have to make sure that that's true. It's a precondition. It's going to be assumed true. Now, to write this code, we're going to start off with steps. Okay, all algorithms start off with steps. So what do we want to do? Well, if we have a list of numbers, how do we find the maximum? Well, we need a variable to keep track of what the largest element is. Okay. We need to keep track of the index of the largest element as well. So we have to keep track of those two things because we're going to be looking through the list. And as I find the max, I want to make sure that I have a variable that's going to accurately update it as I go through the list. How do I go through the list? I traverse the array. We just got done talking about one-dimensional array traversals in the last lesson. So one of the steps is going to be to look through every element of the array. Now, if I'm in the array element and I have an element, what do I want to do? I want to check if that current element that I'm at is bigger than the max I currently have, bigger than the largest element I currently have on file. And if it is, I have found a new largest element, and I've also found an index of the largest element. So I need to change those variables and update them to reflect that, hey, I've found a new max, right? As I'm going through my lists, oh, here's a new max. Okay. Then I keep going through my lists. Oh, here's another new max. And then maybe I finish off my list and I don't find another new max. Well, then here's my max. I found it and I want to return that information. Okay. So these are our steps, right? These are the steps. These are the pseudocode, not necessarily pseudocode because they're just English steps. But you can also write out these steps as pseudocode as well. But when you're working with an algorithm, writing out these steps is very helpful. Okay, so let's write our method. We're just going to write a static method, int, because we want to return the index of the largest number. So we're going to return a single index that represents the largest number, the index that represents the largest number, from a passed array. So the array that's going to be passed, we're going to call it R. All right, so step 1 and 2. Keep track of the largest element and keep track of the index of the largest element. Now, when we say we want to write code that applies to any set of data, any one-dimensional set of data, we don't know what that data holds. We don't know if that data holds all positive numbers, all negative numbers, a mixture. We just know it's all integers, right? So a lot of students, they want to start off by saying, okay, the minimum value is 0, okay? Or the max, and then anything that we go from, when we look at elements in our array, it's going to be higher than 0. You try to make a case for what your beginning value should be. But the easiest and most correct way to get these variables started is to say, hey, we're going to call the first element, we're going to call that our maximum value. Okay, maybe it is. Maybe the first element's the max and all of the numbers I look through and traverse through in the rest of the array, maybe it's all going to be less than that first element. And then perfect, I have my max. But we're going to call the first element and that first index of 0 our current max values. We're going to set them equal to that. So then now we're going to look through the rest of the array, which is step 3. Okay, so this is step 1 right here. And then this is step 2 right here. Step 3, we want to traverse the array. Okay. Now, because I've already set my first index and my first element as my max, I'm going to start at I equals 1 for this traversal. You could easily start off at I equals 0. You just check the max against itself, essentially, which wouldn't be incorrect, okay? You can do that. But I want to traverse through all of the other indexes that I haven't looked at, okay? So that's my for loop header, to traverse through the entire array, one index at a time. Now inside the body, I have step 4. Check if, okay, so an if statement, the current element, okay, the current element being Ri, is bigger than the largest element, okay? So if the current element is bigger than what I currently have as the maximum value, what do I want to do? Well, if it is, I want to do step 5, okay, which is going to be inside my if statement here. Okay, so step 4 is this if statement, and then step 5 is what I want to do with that information. So if the maximum is less than the current element that you're at, then hey, you found a new maximum value. So you're going to set max equal to Ri, the current element, and max index equal to I. Okay, so you're going to keep track of that. And then you're going to move on to the next element and the next element. You're going to keep going through. And at the very end, what is the information you want to return? You want to be careful with these algorithms to return the correct information. This algorithm didn't want to know what the largest number was. It wanted to know the index of the largest number. So that's why I'm going to return max index at the very end here. And I've written my method called max. Okay. Now this algorithm is to find a max value. I'm going to ask you to find a min value in the homework, but little hint here, for a min, you just change this, okay? You just change that. And then all of a sudden you have an algorithm and the code for finding a minimum value in an array of integers, okay? Very exciting. All right, algorithm 1. Algorithm 2, compute a sum from an array of integers. We actually did this in the last lesson, but let's define it a little bit more formally here. It says write a method called sum that returns the sum of the elements in an array that is passed to the method. So again, the precondition, you're passed a non-empty array of integers. Let's go through. First, we need a variable to keep track of the sum. We need to traverse the array, and we want to add the current element to the sum variable. Okay, we don't have to check anything. We don't have to ask a question. We just take the element we're currently at and add it to sum. And those are our steps. Okay, and then return the sum. Those are our steps. So let's write this method. Public static int. Int represents the sum that I'm going to be returning, and then I'm passing it an array. So I'm going to write code that's going to apply to every single type of array here, of array of integers. So I'm going to keep track of the sum with a variable int sum equals 0. I'm going to traverse through the entire array. So I'm going to start at index 0 and go up to not including r.length. And then I'm going to take the current element and I'm going to add it to sum. Again, current element here, and I'm going to add it to sum. Okay, keeping a running track of what sum is. And then after I traverse through the array and do that for each array element, I'm going to return the sum. Okay. And that's algorithm number 2, compute a sum. Okay. Notice how if we wanted to compute an average, right? Computing an average from an array of integers is just one more step. You take the sum and it's just one line. You just take the sum and you divide it by the length of the array, right? So you can take these common algorithms and you can kind of just shape them to what you might need. And that's why these are kind of like the base of the algorithms we see. Algorithm 3, determine if at least one element has a particular property. So an example of this type of algorithm, write a method called any negatives that is passed an array of integer values and will return true if there is at least one negative value. Okay, so this is going to return true if there is at least one negative in an array of integers. So again, passed a non-empty array of integers. What's this going to be? Well, we're going to look through the array. So we have an array of integers. What do we want to do? We want to look through the array. And as soon as we find a negative number, we return true. Okay, if we go through the whole array and we don't see any negatives, we're going to return false. Okay, so traverse the array. Check if the current element is negative, because if it is, we want to return true because a single negative was found. Maybe if we wanted to count the negatives, we could change this code to just count the negatives. But in this case, we're just returning true. Bam, found a negative, return true. Okay? But if we go through the entire array, we never found a negative, after that loop, we're going to want to return false. Okay? The negative was never found, so we return false. What does this code look like? Okay, public static Boolean, because we're returning a true false value. Any negatives were passed an array of integer values here. Okay, we're going to traverse through the array one at a time. We're going to check if the current element, if it's less than 0, we're going to return true right away. Okay, loop is done. I don't have to continue the loop at all. I just return true. If I go through the entire loop and I don't find any negatives, I'm going to return false. Okay. Awesome. Algorithm 3, determine it. And there are a lot of different ways we could write this problem. A lot of different ways, instructions that are going to be given, and we have to use this kind of algorithm. But know that this loop header, this traverses the entire array. And then if we want to check for a particular property, we use the current element and we ask an if statement. We use an if statement to ask a question. Okay. Algorithm 4, determine if all elements have a particular property. Okay. So this is called, write a method called negative array that is passed an array of integer values and will return true if there are all negative values. Okay. So a little bit different, but kind of the same thing. We're working with negatives. So returns true if all negative values. Oops, this instruction is, I'm going to change these instructions because I copy and pasted from the last one. But this is going to return true if there are all negative values. Okay? Again, precondition, pass a non-empty array of integers. Here are our steps. Okay? Traverse the array, Check if the current element is positive. Okay? Why am I checking if it's positive if I'm looking for negatives? Well, if I find one positive, I'm going to return false because of the way the instructions were written. As soon as I find a positive, return false, meaning that the array is not negative. I'm going to return true after this loop because if a positive was never found, that means that all of them were negative, right? Okay. Now, this is some, I wasn't very careful about where 0 falls, okay? Where 0 falls in this, but we're going to assume, or the way I have this written, we're going to assume that 0 is going to be a positive number, okay? I should have written it better, but it is what it is. So we're going to return a true or false value. We're passed an array of integer values. We're going to traverse through the entire array. And if we find a positive, or I guess the way I have this written, if the current element is greater than 0. So I don't include 0 here, which means I'm not making 0 a positive number. Okay. The instructions that might be given on the AP exam or on your assessment that I write, okay, it is going to be a little bit more clear about how you should handle 0 in those situations. Okay, so this is saying if the current element is greater than 0, if it's positive, return false. Okay, meaning that since we found a positive, the array is not negative numbers. Okay? But if we loop through everything and we never find a positive number, return true because they were all negative. Say with me. Okay. Algorithm 4. Algorithm 5, we have 7. Okay, we're on 5 of 7 here. Determine the number of elements meeting a specific criteria. Okay, so this one, write a method called 3 multiples that returns the number of elements in an array that are evenly divisible by 3. Okay, so what do you want to do here? You want to have a variable to keep track of how many elements are divisible by 3. You want to look through the array one at a time, looking at each element. Take that element, check if it's divisible by 3, and if it is, you're going to add 1 to count. Okay? If it's not, you don't want to do anything. Okay? Nothing happens. Okay? So we'll only have a single if statement because of that. No else statement because we don't want to do anything if it's not divisible by 3. Okay. And then I return the count. So my method header here, the int that I'm going to return is the count. How many elements were evenly divisible by 3 in this array that I pass it. So I'm going to have a variable to keep track of the count, and I'm going to return count at the very end. I'm going to traverse through the array, check if the current element that I'm at is evenly divisible by 3. Okay. That's how I ask the question, and then if it is evenly divisible by 3, I want to add 1 to count. Do that for each element, and then at the very end, return count. Okay. Remember when I said this for loop header, it's basically going to be memorized for you because this is the for loop header that you want to use when you want to look at every single element in the array. Okay. All right, before we get to the next algorithm, we need to talk about the swapping algorithm here. To swap 2 elements of an array, there's a simple kind of 3-step process here. We store the value of the first element in a temporary array or temporary variable. We assign the value of the second to the first, and then assign the value of the temporary to the second element. So 3 lines of code are needed for this swapping algorithm. What that looks like. A little example of what the swapping algorithm looks like. So consider the set of data of the strings called animals. So I want to write code that's going to swap the position of goat and duck. Okay. So again, these are swapping positions in the list. Okay. So what I'm going to do, so this is array. This is 1, 2, 3, 4. 2, 3, 4. Yeah. Right. I want to switch their position. So I want duck to go here and goat to go here. Okay. Notice how I can't do, okay, this would be incorrect. Animals 4. And this is how, if you've never seen the swapping algorithm, this is how I end up having a lot of students try to write it. because when you first look at this, it looks like it's swapping them, right? You want index 4 to go in the position of index 1 and index 1 to go in the position of 4. Okay, but why doesn't this work? Well, this says take animals 4, which is duck, and store it in animals 1, which means that goat gets overridden, and this is called duck. And then this says take animals 1, which is duck, and put it in animals 4, which is also duck. Okay, all of a sudden goat got overridden, and you don't know where'd goat go. Okay, which is why we introduce a temporary variable to hold the position of goat and hold the value of goat in that temp so that it doesn't get lost in this crisscross applesauce. Okay. So we make a temp variable, and that's going to hold the position of goat so that now I can say, okay, take duck and put it into goat. Okay. Take duck, put it into goat. So now it's duck, duck, and duck right here after this line of code. And then now the temp variable that held goat, now you can put that in position 4, and now goat actually goes where it's supposed to go. Okay. So 3 lines of code have the swapping algorithm. And when you can recognize, hey, this is the swapping algorithm in context here, you can say, okay, yeah, it's just going to swap those 2 elements, and you don't actually have to trace through and see that it does. Okay. A lot of students memorize this because these 2 are the same, these 2 are the same, and then the temp and the temp kind of circle around here. Okay. So you'll probably have the swapping algorithm memorized, especially by the end of this unit, Unit 4 data collections, because it's a big unit dealing with a lot of data. But for right now, just know that that's your swapping algorithm. Why is that useful for us? Well, that brings us into algorithm 6, where we can shift or rotate elements in our array, whether we want to shift them left or right by 1 or rotate them in some way. Okay, so we're going to write a method called shift left that will take an array of integers and shift all the elements to the left. The element at the beginning of the array should move to the end of the array. Okay, what does this mean? Okay, so if I have like 10, 20, 30, 40. I want to shift all of them to the left, which means if I want to shift 40, 30 over, 20 over, and then it says take the element at the beginning and put it at the end. Okay, so if 10, 20, 40 was my original array, by the end, I want my array to be 20, 30, 40, 10. Okay, shift everything 1 to the left. Now the algorithm for this, we're going to use a temp variable to hold this first element. Okay. Then we're going to traverse through the array, and we have to be very careful now to watch the boundaries. We're going to move the next element over to the left. I think I got my lefts and my rights mixed up. Move the next element over. Okay. So 10, again, if I'm 10, 20, 30, 40, 10 is going to be locked away inside a temp variable. So what I'm going to do, I'm going to traverse through the array, and I'm going to move 20 here. Then I'm going to move 30 over. Then I move 40 over. Okay, so I'm going to have to pay attention to the boundaries here and where my current element is starting. So I probably am going to start here. Okay, or maybe start at the start and move my element over 1 by 1. And then the last element in the array is going to be equal to the 10. 10 is going to be stored away safely. Okay, let's see what this looks like. Void, because I'm not returning anything, I'm modifying the array contents. So because I'm modifying the array contents, I don't need any sort of return statement here. We're going to call it shift left. So again, temp variable to hold the first element. And I'm going to shift through the entire array. Okay, so what did I do here? Sorry, this keeps disappearing on me, and that's a little annoying. So 10 is locked away. So what I'm going to do is I'm going to start at the first index 0, and I'm going to take what comes next. So if this is currently I, I'm going to take what happens with I plus 1, and I'm going to put it in my current position. Okay? And I'm going to do that each time. And the reason why I have to watch my boundary right here, okay, is because when I get to this very last, so I get to this one, I want to put 40 in this spot, but I don't want to go all the way up to the last index, because if I go to the last index, there's nothing for me to pull off to the right and pull it into the left here. Okay. And because of that, I would get an index out of bounds if I didn't have this -1. Okay. I only want to go up to here. So if I have index 0, 1, 2, 3, I only want to go up to 2. Okay. My length is 4. So I'm going to do 4 minus 1, which is 3. And I don't want to include 3 because there's nothing to pull after 3. You'll also see that right here. Okay. In the I+1. Okay. And that's kind of the offset that we have to use. And I don't want to say you have to memorize this offset, but it's kind of the pattern. If I use I in my header, okay, I less than r.length, I can only use I in my body. If I use r.length -1, sorry, I'm overwriting here. In my body, I can use up to I+1. If I use -2, r.length -2, I can use up to I+2. Okay. If I use -3, I can use up to I+3. Okay. And that got a little sloppy, so I'm sorry about that, writing that on there. But that is how I can make sure that I'm accounting for the boundaries. I don't want to go out of bounds. So if I use I+3 in the body of my loop, I have to make sure that my eyes don't get too high so that when I add 3, I'm all of a sudden reaching for an index that does not exist. Okay. And it's vice versa if I go low. If I go I-1, I have to make sure that I don't drop below index 0. Okay. Or I-2. I can't go and I can't grab an index that is below 0. So you really have to watch your boundaries when you're writing these algorithms. Okay. And it takes a little bit of practice to understand how to see them and understand the patterns that kind of lead you to checking the boundaries. Okay. Okay. And then what do I want here? How did I write this? So I moved every element over to the left. Sorry, this should be left. I moved every element over to the left. And then once I got to that last element, I want to put in my temp. Okay, whatever I stored in my temp and I tucked away safely, I want to now put that at the very last element. And since I don't know the length of my array ARR, I have to make sure that I code that. So what do? Well, the last index is going to be ARR.length -1. That's always the very last index. So I'm going to get that last index here. And at that last index, that's where I want to put my temp variable. And then I'm done. I've modified the contents of my array so that I shifted everything over to the left. All right. Very exciting. All right. The last algorithm. We're going to go through this algorithm and then we're going to finish our notes today talking about arrays of objects. Okay. So reverse the order of the elements. Okay. If we want to reverse all the elements in an array, we're going to write a method called reverse that will take an array of integers and reverse the contents. Okay. So what I mean, if I have an array 3, 6, 7, 10, a reversed array, this array should be at the very end, 10, 7, 6, 3. Okay. And this has to work for any array. Okay. So what can I do? I'm going to traverse the beginning half of the array. I'm going to find the corresponding index in the end half of the array and use swapping algorithms to swap those two. Okay, so if I have my example 3, and always write an example. If you need help figuring out how do I do this, how can I make this work with my algorithm steps, write out an example. Okay, so what I mean here is we're just going to go through half of the array. So we're going to cut the array in half and we're going to go through and we're going to find the corresponding positions and we're going to swap them. So the first time through this algorithm, okay, this is going to be my contents of the array. And then the next time through, I'm going to swap these two. And then once I reach the middle, following that algorithm, once I reach the middle, I'm done. My array should be swapped. Okay. Now, if I have an odd number of elements, let's say I had a 5 in there. Okay. The odd number, if there's an odd number of elements, the middle element in that odd will just be in the same position, right? So you see that? So I am only concerned about the first half, okay? And I need to make it work whether it's for an even or an odd amount of elements. So this is what it's going to be called. Again, we're modifying the array. We are not returning anything, so it's void. And I want to go through half, okay? So I equals 0, I less than r.length in half, okay? And confirm in your head that that works with an odd or an even number of elements, okay? If my length is 4, half of the array means that 4 divided by 2 is 2. So that means I'm going through index 0 and 1. Okay, which is perfect. That's what I want. If my array is length 5, 5 divided by 2 is still 2. So that still means I'm going through just indexes 0 and 1. And I don't touch index 2, which would be my middle index. Okay, so this works. Okay, this checks out. It goes through the first half, whether or not I have an odd number of elements or an even number of elements. Okay, so it says find the index of the element in the end half. So I represents the element in the first half, right? So if I have 3, 6, 7, 10, I represents the index that I'm currently at, which starts off as 0, okay, in half of my array. I need to find this corresponding element. How can I do that? Well, I'm going to take the length. I'm going to, and then -1, because that gives me the very last index. And then I'm going to subtract I from that, so that as I increases this way, it also decreases this way, so that I'm moving in from the very ends and I'm moving in all the way till I reach the middle. Okay. And so that's going to be the formula that I use for that. And that's going to be the middle end. That's just what I called it. Middle end right there. And now what do I want to do? Well, now that I have this index and this index, I want to swap those two. So I'm going to store a temp. I'm going to swap and swap. Okay? So this right here is the swapping algorithm we just talked about. The swapping algorithm. Okay, swap some. And then we move on to the next one, right? So we started with 3 and 10, swapped them. Then we go 6 and 7, swapped them. Okay? And for longer elements, you just move in. And by the time you get to the end, everything has been swapped. Reverse the order of the elements. There's different ways you can do this. That is not the only algorithm to do it. You can definitely invoke other arrays, other variables, other temp variables to hold values as you swap, rotate. If you wanted to do more of a shifting in order to reverse the order of the elements, you can also do that. There's a lot of different ways to write this algorithm as well. Okay. So you'll learn as you start writing more and more algorithms and getting used to it, you're going to find your own way of thinking and your own way of doing it. And luckily, on the AP exam, especially when you're writing your free response questions, they welcome any and all ways to write algorithms, okay? As long as it works. Okay, we're going to finish up the lesson today talking about arrays of objects. So arrays can hold any data type. So we've obviously done the ints, the doubles, the strings, the booleans. They can also do objects. Okay, so when visualizing an array of objects, think back to our dog class from the units we've done before. Okay, so let's say we want to create an array of dog objects. Here's the syntax we would use. Easy peasy, right? So dog, doggy list equals new dog. So we would have dog here as our variable type. And then let's say we want to make 4 doggies. Okay, so it still follows the same index as arrays. And here's what it looks like. This is what happens in memory. When you make a doggy list of dog objects or any objects, it's always going to be null. Okay? Because it's the default value for an object, except strings. Okay? Default value, or is it strings? No, it's the default value for strings too, for an array. Would be null as well. And yeah, no, it is. For doggy list, strings are weird because they're sometimes primitive, sometimes reference. It's hard to remember sometimes, okay? So it would also be null though. When you make a list and we make an array of a reference type, it's always going to be null, okay? So what do you have to do? Well, this creates 4 dog references, but because the objects have not been created, each value has a null reference to it. So to create the dog, you still have to call in a constructor for each dog element in the array. Okay, so here's what I would do for this. Doggy list 0 equals new dog. And that would use the default constructor there to create a new dog. Unknown name, 0 age, true, they're a good dog. Doggy 1, I can also use the parameter constructor. Fido, he's 3 years old, and true, he is a good dog. Doggy list 2, Bubbles 10, and doggy list 3, Mallory 2, false. Okay, Fido, Bubbles, and Mallory. So I had to use 3 lines of code to create my my dogs for each of them. Okay, so remember with your objects are only created with that new constructor. So the array was created with the new constructor, but then you had to use your object constructor for it. Okay. Here's another way. This is not, this way actually isn't covered on the AP exam, but it is another way of doing it. You can create the array and call on the constructors all in one line. Okay. Again, this is an exclusion on the AP exam. It's not covered, but here's another way of doing it. If I say dog other list, I can, in the curly brackets, okay, so remember these curly brackets, create an array with initial values. And between those, you can call on the new constructor. Okay. New dog Hulk 2, new dog Thor 8, false. Okay. Just another way of doing it. Okay. Now let's talk about using it. So now that we have a doggy list and all of our dogs are created, we can use them. What do the following lines of code print to the console? Okay, so let's trace through and let's see this. So if I have system.out.println doggy list 1.getName, okay, trace through what that means. Doggy list 1 is the dog at index 1. Who's the dog at index 1? Get their name and print it off. This is going to print Fido. Okay. Here, doggy list 0.setName Peaches. Okay. So doggy list 0, and we're going to set this name to be Peaches. Now, if I have doggy list 0, get the name, we're going to return Peaches and print off Peaches. We can also traverse through our array of dog objects. What do? Let's say we go through doggylist.length, and let's say for each dog in doggy list, set age to doggylist.getAge plus 1. Okay, so a lot going on. I'm using some of my accessor and mutator methods here. So inside here, I say, okay, get the current dog, get their age. So at the current dog, get their age, add 1 to age, and then take that value and set it to their new age. Right? Did we follow that? Okay. So take the current element, get their age, add 1 to it, and then that becomes their new age. Okay. So all of these get 1 added to their age, and it's going to become their new age. Right? Oh, now we have a for each loop here. We can use for each loops. Remember when we want to just access elements in our array. We cannot use for each loops to modify, or if we need an index, we can't use a for each loop. But here, let's just say I want to display all of the dogs, their ages. I create a new dog object or new dog reference called puppy. So for each dog in doggy list, puppy.getAge. So that means at the first element, puppy is going to point here. Okay. Puppy is our reference. Puppy is going to point here the first time through. Okay. So puppy get age is going to be 1. Then puppy is going to point here. puppy get age is going to be 4, print off 4. Then puppy is going to point here. Get age 11, print 11. Then puppy is going to go here. Print age 3. And you'll get that all in one line with a space between. Okay. Look good? Hopefully? Yeah? All right. And that brings us to the end of this lesson. You guys, thank you so much for following along. If you have liked this video, please hit the like button and subscribe to my YouTube channel for more great AP CSA content. And until then, I will see you in the next video.